For more videos, visit forthesakeofeducation.com. Alright, now we're going to do this problem where you have a distribution of soil. Loading the bottom of the building slab is shown. Replace this loading by an equivalent resultant force and its location measured from O. So as you can see, we have we have four shapes. Let me divide this into easy geometrical shapes, which is rectangles and triangles. We got a rectangle right here, and we got a triangle right here. Then we have another rectangle right here and a triangle right here. So we got four distributed loadings that we're gonna do. This thin rectangle acts right at the middle of the rectangle. Let's call it F1. This one acts F2, this triangle, and it acts at 1/3 from the long edge of this triangle. F3 is this thicker rectangle, and F4 is this smaller triangle, F4, and it acts at 1/3 of the length of this triangle. Alright, so now let's find the forces. F1 is the area of the thin rectangle, which goes from 0 to 50, so it's 50 times the length of the thin rectangle, which is 12, and this is equal to 600 pounds. F2 is the area of the bigger triangle. It goes from here to here, which is from 50 to 300. Let me put it right here. This is the height of the bigger rectangle, and it's 250. Why 50? Because it's 300 at the tip and 50 at the bottom. That will make it 250. So it's 250 times the length, which is 12, just like the thin rectangle, divided by 2 because it's a triangle, and it comes out to be 1500 pounds. F3 is the thicker rectangle, which has a height of 100 pounds per foot, times the length, which is 9 feet. And it comes out to be 900 pounds. And last but not least is F4, which is a triangle that goes from 100 to 300, which means it has a height of 200 pounds per foot. So it's 200 times the length, which is 9, and divided by 2 because it's a triangle, and that's the area. And it comes out to be also 900 pounds. So now we need to find the lengths at which these forces act about O. Let's go to F1. This length F1 is equal to half of the length of the thin rectangle, which is 12 divided by 2 is 6 feet. The second force acts at the length of the triangle minus 1/3 of that length. 1/3 of the length of 12 is 4, so it would act at 8 feet. The third force, let's call it F3. I'm getting over it doesn't matter, you know what it's asking you to do anyway. So F3 acts at right half of this rectangle plus the length of the thin rectangle, which means that F3 acts at 16.5 feet, 16.5, and F4 is slightly shorter. F4 acts at 1/3 from this long edge plus the length of the thin rectangle, which will make it 15 feet. Now that you got the lengths, you know that they're all turning it counterclockwise. So let's find the resultant force. The resultant force is the addition of all these forces. They're all aiming the same way, up. So let's assume upwards is positive. So the resultant force is 3,900 pounds. The moment is given by F1 times the lever arm that is turning, let's assume counterclockwise is positive. F1 is turning the 6 feet lever arm, which is 6 of course, plus F2 is turning the 8 feet lever arm, plus F3 is turning the 16.5 feet lever arm, and F4 is turning the 15 feet lever arm. When you plug all the numbers in, you're gonna get that the moment is equal to 43.95 kip per feet. I already converted it. Now you want to know the distance d from O that this equivalent force will be acting. Easy to find. The moment is equal to the resultant force times the distance d. We got the moment at 43, that would be 9500, actually 1, 2, 3, sorry, 1, 0. Let's put 43.95 kip feet is equal to 33.9 kip, because it's 3,900 pounds is equal to 3.9 times d. You solve for d and you get that this is equal to 11.27 feet.
Please comment below if you want me to do any problems and I'll be happy to help. Thank you.